The next topic that we're gonna do would be capacitance. Capacitance is basically a topic about capacitors, and capacitors are basically solid state electronic device that stores energy by redistributing charge. So the symbol of a capacitor is like this. It's two parallel plates with wires coming out. In reality, capacitors basically look like cylinders with wires like this. I'm sure you might have seen these, especially those people who have an interest in computing. They might seen they might have seen this capacitors in a motherboard. So if you ever look into your computer, you might find these cylinders. These are capacitors. All right, you guys. Okay. They're basically on almost all electronic devices. Now, capacitance itself depends on
सही ये रजिस्टर जैसा दिखता है.
resistor नहीं होते resistor तो resistors ऐसे होते हैं sorry resistors are like red blood cell types ऐसे so you could say these ये जो नजर आ रहे हैं ना these you see this these are resistors these are capacitors
कैसे?
yes okay so the thing we need to understand is oh I see the color that each capacitor has a capacitance. Okay, capacitance is the ratio of charge on one of the plates. So this is the first mark you're going to get. The second mark for this definition would be to the potential difference across the plates. Obviously, you guys need to write this together, but this is how I've segregated it because this definition will be there often, and this is of 2 mark. The symbol for capacitance is C. The formula for capacitance is C equals to Q over V because charge over potential difference, like that.
You said, sir, that it's the ratio of one of the plates charge over the potential difference.
That's
So
correct.
which plate do we choose?
Anyone, both will have same redistribution. I'll show you that in a bit. But charge on one plate divided by the potential difference across both of them. I'll show you the distribution, don't worry. Then we're gonna look at this that this is basically a scalar quantity and the SI units for capacitance is coulombs per unit volts or farads capital F. Usually these quantities, na, this farad is a very big unit. So usually you will find units like microfarad, millifarad, nanofarad like this. Usually these are written like this. Is it clear? Usually in micro though. Understood?
Yes.
Now, what I'm basically talking about is the charge on one of these plates, like he asked me. So I want to know what exactly that means and how is capacitor working. So basically inside the capacitor, we have two plates, two metallic plates like this. And then you got shape like this. Sorry, that's bad. Like this, okay? On the other end, obviously, we have to connect it with a source or a battery or something like that. So suppose this is the positive terminal, this is the negative terminal, and now we are interested in finding the potential difference across this these two plates, like that. Okay. Now, check this out, please. What happens is, in reality, let's suppose this plate, you can call this plate as X, let's call this plate as Y. So the plate that is connected to the battery being at higher potential, the electrons from X plate are gonna leave this plate and they're gonna travel towards the battery. When it travels towards the battery, what happens is that they leave their positive counterparts right on the plate. Do you get it? Now, when a sort of charge develops on X, to balance this, the negative side of the terminal sends electrons towards the other plate like this, and the negative starts to gather on the other side. So it's sort of, if six charges have left X, six charges will enter Y. Do you guys get it? So what are we really doing? The battery is doing work to redistribute these charges from one point to another. So overall, if you see, the charge that is would be 6 on this. So we just need to take charge on one plate and the voltage that is developed across this. Do you understand now? Uh, Fun?
All right.
Any questions now?
No, can we just copy this?
Yes. Not yet. Wait. In fact, if you try to open up a capacitor, you will find that inside it there is also like a medium, sort of a cottonish medium, which is basically called the dielectric. Dielectric is basically an insulator. And why do we need to place it inside this, in between the plates? Because we don't want that these electrons make a jump from one plate to another directly from this. We don't want that. We want them to get, redistributed, not jump from here. So we want to prevent that from happening. All right. So you can say the dielectric prevents electrons from jumping to the other plate. Okay, now you can basically draw this. So also write few things here. You can say there are equal number of positive and negative charges on each plate. Number 2, reason for placing a dielectric is to prevent charges jumping to other plate directly, as we do not want induction to take place. This process where they jump is called induction. Okay. So you can write this please. Okay, should I go forward now, everyone?
Yes, yes.
Okay. Now the question is that what you have seen right here is a process of how electrons redistribute themselves from one end to another. We also want to write this down because this question will come for at least 5 marks. So because in this chapter a lot of writing is also required. So the question is how a capacitor is charged. So we're going to say number 1, when the switch is closed, potential difference is experienced, due to which electrons move to the positive terminal.
In this case, positive terminal means the terminal of the battery.
Yes, yes. And then the supply from negative terminal provides electrons to the other plate. Okay, so first point, then the next. As the negative charges are displaced from X, they are redistributed by the supply to other plate Y. Then, as more and more charges are redistributed, the potential of supply and the potential of potential across the plates becomes equal. Since potential difference becomes zero, hence the charges stop flowing and charging terminates. The work done by the supply is stored as energy in the capacitor. So that is what is happening here. Okay. You can write this down, then you're going to go forward. All right, you people. Done? Should I go forward?
No, sir.
Just a minute, sir.
Okay.
सर लास्ट पॉइंट क्या लिखा हुआ है? The work done by the supply is stored.
Stored as energy in the capacitor.
सर मैंने लिख लिया.
Okay, very nice. Just a second. Okay, my people, now let's go. So now from this point onwards, we're gonna learn that how the charging works and how we can draw the graphs of these. So charging graphs of a capacitor. Capacitor. Okay. So we're gonna basically build sort of a diagram, or you'd say a circuit. We're gonna learn how we can manage this. Okay. Wait a second. Wait a second, please. I'm drawing. You guys draw. Okay, so basically we have a battery, we have a capacitor, and then in here you also need to have a resistor, like that. Okay. So this is sort of circuit that we're going to use. Please draw this. I'll be back in 1 minute. I just need water. All right, you people. Now, so the configuration that we're going to use when charging the capacitor, we want the capacitor to be basically connected to the battery first. So in this case, we're going to use this two-way switch. That the switch basically connects here. This is basically two-way switch, and when it's connected to point A, it means now capacitance and battery is connected. The resistance is not, right? So as this will happen, so obviously you guys know that electrons will travel towards the battery, and electrons from the other end will come onto the plate like this. So it will be redistributed, which means it's going to charge. So at one point, when this voltage, which the battery has, becomes the same voltage as this, it will terminate. So what it means is that's now fully charged. So in the first one, we're gonna look at the voltage graph, and for the voltage graph, it will be something like this. So V and V, and this is time in seconds. So it's gonna show you a curve. So the voltage is going to increase, and then it is going to become constant like this. And the point where it becomes constant is when the voltage of the battery and the potential difference across the capacitance is equal. Do you guys understand what I'm saying? So these points, this point will be the same. Yes. So you can draw this graph then. So the question then comes in my mind is that why charging is faster at start and slower at end, right? So why is it like it has a decreasing gradient? This is what the question is. So the idea behind this is that first of all, potential difference between capacitor and battery keeps getting less. Like I told you, that basically it was no voltage. The potential difference here was zero initially, and then it keeps on building it up. And when the voltage becomes same, so the potential difference becomes zero and charging terminates. Now, the next point would be a great repulsive force on the plate for incoming charges develops. So obviously, imagine this. This is your plate. Now already you have like it's filling it up, and now sorry, my God. So it's filling it up, and now more electron wants to enter. So as already there's so many electrons, and negative charges basically repel negative charges. So obviously it's gonna sort of try to try to stop this electron from coming in. So the capacity is getting full in that case, right? Yes, Fatma, I'm sorry about that. You got to see the recording. Oh, sorry about that. Okay, then the next thing, so less and less space is left for more charges as charge density increases, right? So it's just like, on, I don't know about you people, but in my family, when there is a wedding, everybody starts to gather at one place. So let's suppose the person who's hosting has 10 rooms. Sorry, 10 is a lot. So 3 rooms, and they're like, 3 families have already come up, and they've occupied those. So if a new family comes, they try to put them into a hotel, right? Because the capacity of the house is full. So just like this one, if the charges is there already, now they don't want more charges because the volume, there's certain density that can be can be achieved. More than that, you cannot put more charges into places, right, within the plate. So that's why the space is finished in that sense. Okay. Okay. Everybody understands this? Should I go forward now?
Yes.
All right. Then we can also see what happens to the charge on one of the plates. So then we're going to look at the graph of charge on one of the plates. So basically it behaves very similar to this. You have charge in coulombs and time in seconds. So it's basically behaves the same way. So it would reach a point where now charge will be maximum, and now it will stop because uh, more charges cannot enter. Finally, we can look at the current, and what happens to the current is opposite of all of these. So initially, because the potential difference is more, so the current is like it goes faster, but as the repulsive force increases, the current basically slows down to terminate. So it's basically sort of a graph like that. So current basically reduces to zero as it becomes charged. Okay. You can draw these, please. Okay. Yes, Abubakar, I agree. That happens, but these times are modern. So the guests get really angry if they're not provided the right comfort. So in old days, that's true. People used to just sleep on mattresses. Okay, now, so basically, this is all the information that you need for charging the capacitors. We're gonna basically stop here because there is a whole. It's true. So basically, we will be looking at discharging of the capacitors in the next class. But for now, we don't have to waste time. For 10 minutes, you can start with the worksheet that's already there, so you can complete it on time. So please go ahead, do that, and we will then meet inshallah on Monday.
Okay, thank you, sir.
And those people, by the way, those people who are like